Good morning, students. Now let's see about the second unit of advanced Java programming. This is remote method invocations. Remote method invocations. This unit contains remote method invocation overview, RMA architecture, developing application with RMA declaring and implementing remote interface, stub and skeleton, registering remote object, writing RMA server, client, EJB introduction, entity bean, session bean, and EJB transactions. Now let's see about one by one. First, let's see about RMI. RMI means remote method invocations. RMI stands for remote method invocations. It is a mechanism that allows an object residing in one system to access or invoke an object running on another JVM, means Java Virtual Machines. RMI is used to build distributed applications. It provides remote communication between Java programs. It is provided in the package java.rmi. RMI applications are often comprised of two separate programs. First one server, second one client. A typical server application creates some remote objects, makes a reference to them accessible, and waits for client to invoke methods on these remote objects. A typical client application gets a remote reference to one or more remote object in the server and then invokes method on them. RMI provides the mechanism by which the server and the client communicate and pass information back and forth. RMI distributed application that uses RMA registry to obtain a reference to a remote object. The server calls the registry to associate a name with a remote object. The client looks up the remote object by its name in the server registry and then invokes a method on it. The illustration also shows that the RMI system uses an existing web server to load class definitions from server to client and from client to server for object when needed. First RMI client, the data moves to RMI server, RMI registry, then URL protocol, then move to web servers, then return back to client. Creating distributed applications by using RMI. Using RMI to develop a distributed applications involve these general steps. First one, designing and implementing the components of our distributed application, compiling source, making class network accessible, starting the applications. These are things. First one, designing and implementing the application components. First, determine application architecture, including which components are local objects and which components are remotely accessible. The steps includes defining the remote interface, implementing the remote object, implementing the client. First, defining the remote interface. A remote interface specifies the method that can be invoked remotely by a client. A client's program to remote interface, not to the implementations classes of those interfaces. The design of such interfaces include the determination of the types of object that will be used as the parameter and the return value for these methods. If any of these interfaces or classes don't yet exist, we need to determine them as well. Implementing the remote object, a remote object must implement one or more remote interfaces. The remote object class may include implementations of other interface and the methods that are available only locally. If any local class are not to be used for parameter or return values of any of these methods, they must be implemented as well. Next one, implementing the clients. Clients that use the remote object can be implemented at any time after the remote interface are defined, including after the remote object have been deployed. Next one, RMI architectures. RMI is always a need for communication between two different applications. In Java-based applications, one application communicates with another remote or different application running somewhere else by using a mechanism called RMI architectures. This RMI architectures of client applications, stub, RMI interface, RMI reference layer, and a transport layer, then pass to this is the RMI architectures. Server-side server applications skeleton. This is the RMI systems. Now, the client application and server applications are the respective JVMs of the client max machine and the server machines. In the RMI application, we write two programs. The client program, which resides on the client, and the server program, which resides on the server machine. Is application layer. Application layer is the actual systems, that is client and the server, which are involved in communication. The Java program on the client side communicates with the Java program on the Java side, on the server side. Next one, step. We have client object from the design introduction. In RMI architecture, it is known as a stub. It is an object that resides on the client machine, and it acts as a proxy for the remote object. It is like a gateway for the client program. The stub has been done the same methods as a remote object. When the client calls on the stub object, and the stub forward this request to a remote object, that is a skeleton, via RMI infrastructure, which is the executed on the server. Stub performs the some events is there. For example, initiates a connection with the remote JVM, writes and transmits parameters to remote JVM, wait for the result, reads the return the result, pass the received result to the caller. Next one, skeleton. And the server object which resides in a server machine is known as skeleton. Stub communicates with the server application with the help of an intermediate skeleton object. And the responsibility of the skeleton object is to send parameter to method implementation and send a return value back to the client. A skeleton performs the some events. For example, reads the parameter passed by the client, invoke the method and actual remote object, transmit or pass the result to the client. Next thing, stub or skeleton layer. The stub or skeleton layer is responsible for intercepting calls made by the client and redirecting these calls to the remote object. This layer is also called as proxy layer. Stub and skeleton are the proxies for client and the server. The stub skeleton objects are like an interface between applications and the rest of the RMA system. Uh, and this layer purpose is to transfer data to remote reference layer by object serializations. This process converting data or object into a byte stream is known as marshalling, and the reverse is known as unmarshalling. Marshalling is performed when requesting the object from the server, and unmarshalling is performed when data or object reference is received from the server. Next, a remote reference layer. The proxy layer is connected to the RMI mechanism through the remote interface layer. This layer is responsible for communications and transfer of objects between client and server. The invocation semantics of the RMI connections is defined and supported by this layer. The remote reference layer is responsible for maintaining the session during the method call. That is, it manages the references made by the client to the remote server object. This layer is also responsible for handling duplicate object. Next one, transport layer. The transport layer is responsible for setting up communication between the two machines. This layer uses standard TCP/IP protocol for connection. The actual transportations of data is performed through this layer. This layer is part of the remote reference layer. Next topic, developing application with RMA declaring. The RMA declaring is some steps to write a RMA program. First one, creating the remote interface, providing the implementation of the remote interface, compile the implementation classes and create the stub and skeleton object using the RMA card tool. Start the registry service by RMA registry tool. Create and start the remote application. Create and start the client applications. First step, define the remote interface. This consists of first one, a remote interface provides describe all the methods of a particular remote object. The client communicates with this remote interface to create a remote interface. Create an interface that extends the predefined interface, a remote which belongs to the package, and declare all the business methods that can be invoked by the client in this interface. Since there is a chance of network issues during remote calls, an remote exception may occur through it. Step 2, developing the implementations class or object, remote object. Implementation class or remote object can be written separately or can be written directly with the server program implementations. To develop on implementation classes, implement the interface created in the previous step. Provide implementation to all the abstract methods of a remote interface. Next, third one, develop the server program. An RMI server program should implement the remote interface or extend the implementation classes to develop a server program. Create a client class from where we want to invoke the remote object. Create a remote object by instantiating the implementation class as so now. Export the remote object using the method export object of the class and unique case remote object which belongs to the package java.rma.server. Get the RMA registry using the get registry method of the locate registry class which belongs to the package java.rma.registry. Bind the remote object create to the registry using the bind method of the class registry. To this method, pass a string representing the bind name and the object exported as parameter. Step 4, develop the client program. Write a client program which the remote object and invoke the request record method using the remote object to develop a client program. Create a client class from where we are intended to invoke the remote object class which belongs to the package java.rma.registry. Fetch the object from the registry using the method lookup of the class registry which belongs to the package java.rma.registry. To this method, we need to pass a string value representing the bind name as parameter. This will return the remote object. The lookup returns an object of type remote. Finally, invoke the require method using the obtained remote object. Next, step 5, compile the applications. Compile the application in the for some manner is this. That's what are these manners now. Compile the remote interface, compile the implementation class, compile the server program, compile the client program, or open the folder where we have stored all the programs and compile all the Java files. Next, sixth one, execute the applications. Step 1, start the RMA registry using the command start RMA registry. This will start RMA registry in a separate window. Step 2, run the server class file Java server, run the client class file Java client. Now, example, RMA example. We have some example all the above steps to create and run the RMA applications, and the client applications need only two files, remote interface and client applications. In the RMA applications, both the client and the server interface with the remote interface. The client applications invokes method on the proxy object. RMA sends the request to the remote JVM. The return value is sent back to the proxy server object and then to the client applications. Okay. First one, create remote interface. Create remote interface. For creating the remote interface, for creating the remote interface, extend the remote interface and then declare the remote exceptions with all the methods of the remote interface. Here, we are creating a remote interface that extends the remote interface. There is only one method named add and it declare remote exceptions. Declare remote exceptions. See the example. This is the example. First step, creating the remote interface. This is the remote creating remote interface program. Uh, Import java.automated star public interface. This interface name adder extends remote public int add int x comma int y throw remote extension. This is only define the interface. Next, second step, now provide the implementations of the remote interface. For providing the implementations of the remote interface, we need to either extend the unique cast remote object class or use the export object method of the unique cast object class. In case we extend the unique case remote object class, we must define a constructor that declare remote exceptions. Like this, import java.automated star, import java.automated server, public class name order remote extends unique as remote object, implements add is here, creating the interface. Like this is the interface order, extends the order. Add remote is the constructor, add remote through a remote exceptions. So super refers to the current variable, public int method add index into the return values to the previous classes. Next, third one, create a stub and skeleton object using the RMIC tool. The next steps is to create stub and skeleton object using RMI compiler. The RMI tool invokes the RMI compiler and creates a stub and skeleton object. Like RMIC adder remote. Now we can create a stub and skeleton object using RMIC tools. Next, fourth step, start the registry service by the RMA registry tool. Now, start the registry service by using the RMA registry tool. If we don't specify the port number, it uses a default port number. In this example, we are using the port number 5000. RMA registry 5000. This is the start the RMA servers by RMA using RMA tool. RMA registry tool. Next, fifth one, create and run the server applications. Now, RMA services need to be hosted in a server process. The naming class provides methods to get and store the remote object. The naming class provides five methods. Public static server automated, public static void bind public static void unbind name, the public static void rebind. Now this is the method. Public static lookup the methods through Java.org not bound exceptions. It returns the reference object, remote object. And some public static void bind method, it bind the remote object with a given name. Next, static void unbinded method, it destroy the remote object which is bound with a given name. This is the five methods. Now I see the example. public class name, static void means there's using the exceptions. So using try and catch blocks. The try and catch blocks is the exceptions. Add stubs will view order remote naming dot rebind. This is a local host and fetch the remotely in the using the local host. This is the regime RMAC tools. Next sixth step, create and run the client applications. At the client, we are getting the stub object by the lookup method of the naming class and invoking the method on this object. In this example, we are running the server and the client applications in the same machine, so we are using local host. If we want to access the remote object from another machine, change the local host to the host name or IP address where the remote object is located. Now, this is the client applications program. I import java.rmi public class name is my client. This is a main method using the exception handling try catch block, creating the order and the stub is a client side. This is the local host is the same class, same machines. Okay. Uh, First, for running this example, first one compile all the Java files. Java C, the start.java. Now compile the all Java files. Second one, create stub and skeleton object by RMIC tools. RMIC add a remote. Third one, start RMI registry in one command prompt. RMI registry 5000. Start the server in another command prompt, Java my server. Start the client applications in another command prompt, Java my client. Okay, this is the how to run the remote method implementation, the RMI program. Next concept we will see about EJB. That is the enterprise Java beans. It's another language. EJB introductions. EJB is a server-side software element that summarize business logic of an applications. Summarize business logic of an applications. EJB is used to develop scalable, robust, and secure enterprises applications in Java. The EJB enumerations aims to provide a standard way to implement the server-side business software typically found in enterprise applications. The EJB run run the EJB applications, we need an application server such as JBoss, ClassFish, WebLogic, and WebSphere, and etc. Advantage of enterprises. What are the advantage of enterprises? EJP repository yields system level services to enterprise beans. The bean developer can focus on solving business problems. Rather than the bean developer, the EJP repository is responsible for system level services such as transaction management and security authorizations. The beans rather than client the beans rather than client contains the application business logic. The client developer can focus on the presentations of the client. The client developer does not have to code the pattern that execute business rules or access databases. Due to this, the client are thinner, which is a benefit that is particularly important for client that run on small devices. Enterprise Java bits are portable elements. The application assembler can build a new application from the bins that already exists. Next thing, types of enterprise Java bins. A session bin and a message driven bin. Next one, session bin. Session bins are Java bin which encapsulate the business logic in a centralized and reusable manner such that it can be used by a number of clients. Session bins are plain old Java object which functions as server-side extension performing business logic. As the session beans server-side extension, they can be accessed by various types of client, like another enterprise beans, a web component such as a servlet, a plain Java class, or web services. There are two types of client access models for session bean, local client access and a remote client access. Next one, the local clients are components residing in the same enterprise applications, while remote clients are components executing in a remote JVM. Now, local clients are components residing in the same enterprise applications, while remote clients are components executing in a remote JVM. Next, types of session bean. Types of session bean. Stateless session bean, stateful session bean, and a singleton session bean. Uh, s- Stateless session beans, it means provide user generic business processing and are not tied to a specific client. Stateful session bean provides user specific business processing and are tied to a specific client. Singleton session bean provide shared data access to client and the components within an application and are initiated only once per applications. Next, message driven bean or EJB beans which are driven with the help of messages. There are two types of message driven bean. First one, JMS message driven bean, non-JMS message driven bean. Next, EJB transactions. A transaction is a single unit of work item which follows the ACID properties. ACID stands for atomic, consistent, and isolated, and durable. Atomic means if any of the work item falls, the whole unit will be considered failed, success means item executes successfully. Consistent means a transaction must keep the system in consistent state. Isolated, each transaction executes independent of any other transactions. Durable, transactions should survive system failure if it has been executed or committed. EJB container or server or transaction servers and handles transaction context propagations and distributed transaction. Transaction can be managed by the container or by custom code handling in bean code. Container managed transaction in this type of these the container manages the transaction states. Bean managed transaction the developer manages the life cycle of a transaction state. Container managed transactions in EJB3 has specified the some attributes transactions which EJB container implements. Record news, support, not supported, mandatory, and never. Record means indicates that business method has to be executed within transaction. Otherwise, a new transaction will be started for that method. Record new indicate that a new transaction is to be started for the business method. Supports indicates that business methods will execute as part of transaction. Not supported indicate that business methods should not be executed as part of transaction. Mandatory indicate the business method will execute as part of transaction, otherwise exception will be thrown. Never indicates if business method executes as part of transaction, then exception will be thrown. Thank you.